Hey guys, let's talk rational and irrational numbers. So what does it mean to be rational or irrational? So we've got two separate sides. We've got the rational on the left, irrational on the right, and we're going to add some things to here, make some extra notes. So make sure you jot this stuff down. A rational number, any number that you can write in the form, and this piece is missing, so right here in this little spot we're going to fill something in. So it's any number that you can write in the form of A divided by B, where A and B are integers. Okay. Integers, which means positive or negative whole numbers, and your B cannot be a zero. That just means it has to be defined. Okay. It has to be a number that exists that's positive or negative whole number. Okay. So a rational number can be that. It also can be a decimal that terminates or repeats. Okay, and then there's one more that we're going to add to this. And we're going to add perfect squares, because we were talking about rational numbers, so we want to know, we were talking about radical numbers, so it's good to know about perfect squares. So let's just give us some examples of each one of these. So rational numbers, for the first one, numbers that can be written as A over B, where A and B are whole numbers, and B is not zero. So something like 1/3, or 4/7. Okay? It could even be something like 4/2, which reduces down to the whole number 2. Okay? So any kind of fraction that have whole number integers, positive or negative, it doesn't matter, as long as the denominator is not 0. Okay? The second one means decimals terminate or repeat. Well, think about some of those numbers that we already wrote, like the fraction 1/3. That would be the decimal 0.333, where it just repeats, where 0.333 repeats forever. That is called a repeating decimal. So that would be okay. That's a rational number. A decimal that terminates is a decimal that stops, kind of like 0.25 or 0.75 or 0.1625, or any decimal that is going to stop at that certain number, because we all know that 0.25 is the fraction 1/4, which fits that A over B form that we just talked about. And then the last one would be our perfect squares. So things like the square root of 4, which is the number 2, or the square root of 25, which is 5, or the square root of 144, which is just the number 12. So as long as it's a square root that is a perfect square, then that is also a rational number. Okay? So on the opposite side of that, we have our irrational numbers. Okay? These are numbers that cannot be represented as the quotient. That just means a division problem of two integers. And the decimal does not terminate or repeat. Okay, well, what's that going to be like? Well, I don't know if you are familiar with this number, but you're going to start seeing it in your next math classes and so on. This is called pi. It is a decimal that does not terminate. It's 3.141597 blah blah blah, and it keeps going forever and ever. So that is a decimal that does not terminate. It could be written like this: 3.14 dot dot dot. Okay, those 3 dots mean that it's going to keep going forever. It's not going to terminate. Okay, numbers like square root of 5, square root 7. These square roots are not perfect squares. Therefore, they would give us decimals that would not terminate. Okay? Similarly, if we did something like square root of 3 over 2. Yes, the bottom of that is an integer, but the top is not. So therefore, it could not be the quotient of two integers because one of them is not an integer. Okay, we might even have numbers that look like, let's say 4 minus the square root of 3. Okay, that is going to give us something that's going to keep going forever and ever. It would not terminate. So these are examples of things that do not fit in the rational, so we call them irrational. Okay, so let's take that kind of mindset, and we're just going to look at numbers 1 through 8 here, and we're just going to identify, is it rational or irrational? All right, so number 1 says the number 5. Well, this is a nice, pretty whole number. That means it's a rational number. Number 2 says 2.567. Okay, you need to make sure you look at it. If it has the little bar written across it, that means it repeats, and if it has the dot, dot, dot at the end, it means it continues on forever. So you need to write those two things down. If you have some kind of number and a line over it, this means repeats. If you have some kind of decimal and you have a dot, 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 that means it goes on forever. Okay, it's not going to stop. It's not going to terminate. Okay, this one, number 2, it doesn't have either of those, so that means it terminates. So this terminates, so therefore, this would be a rational number. Okay, let's look at number 3, 4.77 with a line above it. So remember, this line above it tells us that it's going to repeat that 7 over and over and over. So remember, if it's a repeating decimal, that means it's rational. All right, number 4 is pi. Remember, we talked about pi, and pi is just a symbol that represents that number 3.141597, so on, and it keeps going forever and ever with no set pattern. So this one does not terminate or repeat, so it is irrational. Okay. Number 5 is the number 6 over 9. Now, we don't need to necessarily try to simplify this because all we really do is need to look at the numbers. The number 6 is a nice whole number. It is an integer. The number 9 is an integer. So this is an integer over an integer, so that means it's rational. Okay. Number 6 is the square root of 7. This is not perfect square. Okay, so I'm going to put that on the side. This is not a perfect square. So since it's not a perfect square, it's irrational. If it was a perfect square, it would be rational. Excuse me. All right. Number 7 says 3 plus the square root of 5. So 3 is a nice, pretty integer, a whole number, but the square root of 5 is not a pretty whole number, or a perfect square for that. So that means we're taking something that's rational and we're going to add something that's irrational. So we're taking some whole number and we're going to add a decimal that continues forever and ever and ever. So that just means it's going to be that same decimal that continues forever and ever with an extra 3 in the front. So this is still going to be irrational. And then number 8, we have the square root of 18 over 5. Well, is the square root of 18 a perfect square? It's not. If it was the square root of 16, that would be a perfect square, okay, but it's not. It's the square root of 18. So since that top piece here is not a perfect square, this would give us a decimal that goes on forever and ever, an irrational number divided by a rational. this is still going to be irrational. Okay? So making sure that you can look at the numbers and recognize, is that a rational number or is it an irrational number? Which category does it fall into? This next part right here, there's 4 of them. There's actually 2 more that we're going to add. I want to know, what is the result? Is the result to this problem going to be a rational number or an irrational number? Okay. So the first one says if we have a rational number plus or minus another rational number. Okay. So if we have a rational number plus another rational number, that means we're going to always get another rational number. So this will always be a rational number. Okay. If we have a rational number plus or minus an irrational number, this will always be irrational. Okay, so let's just talk about an example for each one of these. So let's say we have a rational number like 4, and we add the square root of 25. That's rational because it's a perfect square. That's going to give us 9. That's going to give us 9, which is still a rational number. So we have something like this, a rational number plus an irrational number, like the square root of 3, okay? That will always be irrational because the square root of 3 is a decimal that's going to continue on forever with no set pattern, and we're just adding a 4 to it. So it's just making it a bigger irrational number. Okay? If we have a rational number times a rational number, this will always be rational. Okay? Example would be 2 times the square root of 4. Okay, square root of 4 is a perfect square, so that's rational. Okay, then that's just going to give us 2 times 2, which is 4. If we have a rational number times an irrational number, this will always be irrational. Okay, so an example would be like 3 times the square root of 3. Let's add these 2 up to the right. So we're going to add irrational plus or minus irrational. Okay, so if we have an irrational plus or minus another irrational, this is going to be irrational. And then probably the next one is my favorite one. It's if we have an irrational times an irrational. Now I'm going to write this one out so you guys can see why it's my favorite. Let's take the irrational 3 times the irrational 2. This is going to give us a square root 6. So square root of 3 times square root of 2 is square root of 6, which is irrational. But what if we had 2 irrationals that were the same being multiplied? This is the square root of 9, which simplifies down to a 3. So we see that sometimes it comes out to be irrational, and sometimes it comes out to be rational. So that one's probably my favorite, because sometimes it's one thing and sometimes the other. All right, so look down at number 10. And it says, which of the following is all irrational numbers? So we need to go through and figure out if it's A, B, or C. And then on the side it says Sally picked B. Is she correct? Explain why or why not. So go ahead, take a second, pick the right answer, and explain is she correct or not. And then check your answer with mine. All right, on number A, all 4 are rational. On number B, all of them are irrational except for the first one, and on C, all of them are irrational. So Sally is not correct. The square root of 64 is 8, which is a rational number because it's the perfect square. So the correct answer is C. All right. Hope you understand rationals and irrationals.